Welcome to today's ArXiv CS Digest for May 19th, 2026. We received 904 new computer science papers today across 57 subfields. Let's dive into the top picks. Trend 1 of 10, Complex Data Analysis and Modeling. These papers develop advanced computational and mathematical approaches for analyzing, modeling, and interpreting complex data and systems. This cluster covers 68 papers. Representative work includes CritBand, a Python package for critical bandwidth analysis of multimodal distributions, learn static function data structures, and addressing prior dependence in hierarchical Bayesian modeling for PDA data analysis too. Noise and SGWB inference through parameter decorrelation. Trend 2 of 10, Learning for Robotics and Control. Advanced machine learning and AI drive intelligent, adaptive, and robust robotic and control system development. This cluster covers 88 papers. Representative work includes Not Every Rubric Teaches Equally, Policy-Aware Rubric Rewards for RLVR, TrajTalk, Adaptive Spatial Tokenization for Trajectory Representation Learning, and K-Inductive Neural Barrier Certificates for Unknown Nonlinear Dynamics. Trend 3 of 10, LLM Reasoning, Prompting, Evaluation. This trend unifies research on instructing, assessing, and improving large language models' reasoning, reliability, and ethical performance. This cluster covers 129 papers. Representative work includes 1 in 8 OpenAlex abstracts has integrity issues, LLM-MC effect, LLM-based Monte Carlo modeling of effective trajectories and latent ambiguity for interpersonal dynamic insight, and less back and forth, a comparative study of structured prompting. Trend 4 of 10, High-Fidelity Visual Content Generation. This trend explores advanced methods for generating highly realistic and detailed visual content across images, videos, and 3D models. This cluster covers 97 papers. Representative work includes PyGAvatar, Hierarchical Neural Field Guided Gaussian Avatars, Long-Live 2.0, and NVFP4 Parallel Infrastructure for Long Video Generation, and TyGS, Scalable training of over 1 billion 3D Gaussian splatting primitives via out-of-core optimization. Trend 5 of 10, Robust Machine Learning Optimization. This trend unifies research on developing robust and stable optimization methods for machine learning, ensuring reliable performance under diverse conditions. This cluster covers 80 papers. Representative work includes When Does Model Collapse Occur in Structured Interactive Learning? Goal-oriented lower-tail calibration of Gaussian processes for Bayesian optimization, and optimizing computational statistical runtime for Wasserstein distance estimation. Trend 6 of 10, Formal Verification and Optimization. Developing rigorous mathematical methods for verifying system correctness and achieving optimal performance across diverse applications. This cluster covers 90 papers. Representative work includes a first-order method for non-convex non-concave minimax problems under a local Kurtikalo-Jacewicz condition, long-term power grid planning via answer set programming, and verifying equilibria in finite horizon probabilistic concurrent game systems. Trend 7 of 10, VLM Reasoning, Evaluation, and Robustness. This trend unifies research focused on improving vision language models' reasoning, enhancing their robustness, and developing comprehensive evaluation methodologies. This cluster covers 99 papers. Representative work includes MSAV Bench, towards comprehensive and reliable evaluation of multi-shot audio-video generation. From seeing to thinking, decoupling perception and reasoning improves post-training of vision language models, and multi-axis analysis of image manipulation localization. Trend 8 of 10, Interpretable Prediction for Critical Applications. This trend develops interpretable predictive models for critical applications where understanding model decisions is paramount. This cluster covers 124 papers. Representative work includes Atoms of Thought, Universal EEG Representation Learning with Microstates, an empirical investigation of reconstruction-based models for seizure prediction from ECG signals, and GraphPine, Graph Importance Propagation for Interpretable Drug Response Prediction. Trend 9 of 10, Efficient and Advanced LLM Architectures. This trend investigates architectural and algorithmic advancements to optimize LLM efficiency, resource use, and overall performance. This cluster covers 60 papers. Representative work includes TIDE, efficient and lossless mode diffusion LLM inference with I/O-aware expert offload. Core A, compact knowledge representation for large language models. And HIDE, rethinking the zoom-in method in high-resolution LLMs via hierarchical decoupling. Trend 10 of 10, LLM-powered agent design and benchmarking. These papers unify research on designing, evolving, and benchmarking LLM-powered agents for complex, dynamic real-world tasks. This cluster covers 69 papers. Representative work includes ClinSeek Agent, automating multimodal evidence seeking for agentic clinical reasoning, a methodology for selecting and composing runtime architecture patterns for production LLM agents, and The World Won't Stay Still, programmable evolution for agent benchmarks. Up next, our first paper out of 10, Causal Evidence that Language Models Use Confidence to Drive Behavior by Darshan Kumaran and Viorka Petrosyan from Google DeepMind. Let's break down its key contributions. The authors discovered that large language models apply implicit thresholds to their internal confidence estimates when deciding whether to answer a question or abstain. This contribution highlights confidence as the primary predictor of an LLM's behavioral choices. This contribution provides strong causal evidence, showing that directly manipulating an LLM's internal confidence signals correspondingly shifts its abstention rates. It demonstrates a direct link between an LLM's internal state and its external behavior. The research demonstrates that large language models can systematically vary their abstention policies based on explicitly instructed thresholds. This suggests a flexible and controllable metacognitive capacity within these models. The findings indicate that an LLM's abstention behavior arises from the joint operation of internal confidence representations and threshold-based policies. This mirrors the two-stage metacognitive control observed in biological systems, suggesting a sophisticated self-assessment capability. Up next, our second paper out of 10, Causality-Aware End-to-End Autonomous Driving via Ego-Centric Joint Scene Modeling by Siaka Moon and Jungbyum Lee from Korea University. Let's break down its key contributions. The authors introduce CAD, a novel causality-aware end-to-end autonomous driving framework. This system directly addresses the critical oversight in existing methods by explicitly capturing causal interdependencies between the ego vehicle and surrounding agents within a shared latent scene representation. This contribution focuses on an ego-centric joint causal modeling module. It builds upon a marginal prediction branch and learns the crucial causal dependencies that exist between the ego vehicle and other interaction-relevant agents. The system leverages a causality-aware policy alignment stage, which is implemented using joint mode embeddings. This stage works to align the stochastic ego policy with planning-oriented closed-loop feedback computed from the surrounding traffic and map context. Up next, our third paper out of 10, Search Self-Play, pushing the frontier of agent capability without supervision by Ruijin Ding and Guanjun Jiang from Qwen Large Model Application Team. Let's break down its key contributions. The authors introduce a novel self-play training framework, termed Search Self-Play, SSP, specifically designed to overcome the scalability limitations of RLVR for LLM agents. This system leverages an LLM to simultaneously act as both a task proposer and a problem solver. This contribution focuses on the innovative dual role of the LLM within the SSP framework, where it functions as both a task proposer and a problem solver. The task proposer generates deep search queries with increasing difficulty, while the problem solver attempts to handle them, fostering a coevolutionary learning process. To ensure the accuracy and verifiability of generated tasks, the system leverages a robust mechanism for ground truth verification. It collects search results from the proposer's trajectory as external knowledge and then employs retrieval-augmented generation, RAG, to confirm that proposed queries can be correctly answered. The authors demonstrate that their Search Self-Play, SSP, framework significantly improves the performance of search agents across various benchmarks. This improvement is achieved uniformly and without any supervision, applicable to both from-scratch and continuous reinforcement learning setups. Up next, our fourth paper out of 10, FedShield-LLM, a secure and scalable federated fine-tuned large language model by MD Julmia and M. Hadi Amini from Florida International University, FIU. Let's break down its key contributions. The authors introduce FedShield-LLM, a novel method that combines pruning with fully homomorphic encryption, FHE, for low-rank adaptation, LoRa, parameters. This system enables secure computations on encrypted model updates while mitigating the attack surface by deactivating less important LoRa parameters. This contribution focuses on optimized federated algorithms specifically designed for cross-silo environments. Up next, our 5th paper out of 10. Training-free Bayesian filtering with generative emulators by Thomas Savary and Gilles Loup from SAIL, Montefiore Institute, University of Liège, Belgium. Let's break down its key contributions. The authors introduce a novel method where diffusion-based emulators of dynamical systems are used to implement an optimal variant of particle filters. This approach allows for the implementation of this complex filter without requiring any additional training. This contribution focuses on overcoming long-standing implementation challenges associated with an optimal variant of particle filters. The system leverages diffusion emulators to make this previously difficult-to-implement filter practical. The proposed approach successfully scales particle filtering to high-dimensional settings, a significant improvement over previous methods. Experiments on complex nonlinear chaotic systems, including atmospheric dynamics, demonstrate this enhanced scalability. Up next, our 6th paper out of 10, Understanding Inference Scaling for LLMs, Bottlenecks, Trade-offs, and Performance Principles by Moise Arif and Bogdan Nikolai from Micron Technology Incorporated. Let's break down its key contributions. The authors characterize a fundamental paradigm shift in LLM inference, moving from standard generative AI to reasoning-centric architectures that create a new capacity-bound regime. This highlights the unique challenges posed by extensive chain-of-thought processing. This contribution focuses on a comprehensive system characterization across diverse model sizes, systematically exploring parallelism types to identify critical bottlenecks that defy standard scaling heuristics for reasoning workloads. The paper analyzes the trade-offs of different parallelism strategies, showing that data parallelism faces a capacity trap due to KV cache fragmentation, while tensor parallelism unlocks stranded memory and offers sublinear gains, especially for larger models. The authors provide crucial insights into scaling at frontier levels, detailing how dense models are interconnect-bound, favoring high-degree tensor parallelism, while sparse models benefit from hybrid strategies due to routing and synchronization latency. This contribution establishes a rigorous decision framework derived from their analysis, providing new architectural imperatives essential for designing the next generation of inference infrastructure too. Up next, our 7th paper out of 10, Beyond Imitation, Learning Safe End-to-End Autonomous Driving from Hard Negatives by Jiunli Wang and Qichao Zhang from Institute of Automation, Chinese Academy of Sciences. Let's break down its key contributions. The authors introduce a novel flow matching-based negative trajectory generator. This component synthesizes safety-critical trajectories that are close to expert paths, allowing the system to explicitly model safety differences. This contribution focuses on a diversity-aware sampling strategy. It helps prevent mode collapse and ensures a wide range of diverse failure modes are covered during negative trajectory generation. The system leverages a new repulsive distance loss function. This loss simultaneously pulls predictions towards expert demonstrations while pushing them away from dangerous negative trajectories, effectively creating clear safety boundaries. Up next, our 8th paper out of 10, The Silent Hyperparameter, Quantifying the Impact of Inference Backends on LLM Reproducibility by David Pape and Leah Skonher from CISPA Helmholtz Center for Information Security. Let's break down its key contributions. The authors identify the inference backend as a previously unrecognized but critical silent hyperparameter affecting LLM evaluation. They highlight that despite widespread use, the specific inference stack is rarely reported in research publications. This work presents a systematic empirical study that quantifies the significant impact of inference backends on LLM benchmark results. The authors demonstrate that the choice of backend alone can shift scores by up to 16.6 percentage points and induce high rates of output disagreement. The system leverages careful analysis to pinpoint the specific system-level optimizations responsible for this divergence. The authors trace the execution pipeline to identify factors like prefix caching, custom CUDA kernels, and engine-specific logit processing defaults. This contribution focuses on improving the reproducibility and interpretability of LLM benchmark comparisons. The authors advocate for standardized reporting of inference stacks, recognizing their crucial role in evaluation. Up next, our 9th paper out of 10, The Capability Paradox. How Smarter Auditors Make Multi-Agent Systems Less Secure by Qiqi Liu and Runhan Song from University of Chinese Academy of Sciences. Let's break down its key contributions. The authors introduce semantic hijacking, a novel attack where malicious requests are hidden within seemingly legitimate, domain-specific narratives. This attack propagates through worker reports to a manager without relying on traditional syntactic injection methods. This paper uncovers a significant capability paradox in multi-agent systems. It demonstrates that as the capabilities of individual workers increase, the overall system's vulnerability to attacks, measured by attack success rate, surprisingly rises. The authors explain that this paradox is driven by linguistic certainty. Stronger workers tend to interpret adversarial narratives as legitimate and express their conclusions assertively, which then persuades managers to execute these harmful requests. The system leverages a novel defense mechanism called heterogeneous ensemble verification. This approach pairs workers with differing domain competencies to exploit their complementary vulnerabilities, effectively breaking the attack chain and significantly reducing the attack success rate. Up next, our 10th paper out of 10, position, Uncertainty Quantification in LLMs is just unsupervised clustering by Taijin Shun and Huawei. Let's break down its key contributions. The authors argue that mainstream uncertainty quantification UQ methods for large language models are essentially unsupervised clustering algorithms. This contribution highlights that these methods primarily quantify the internal consistency of model generations rather than their external correctness. This contribution focuses on demonstrating that current UQ approaches are fundamentally blind to factual reality. The authors show how models can exhibit high confidence in stable but incorrect answers, leading to what they term confident hallucinations. The paper identifies 3 significant pathologies resulting from the reliance on internal model states for UQ. These include a hyperparameter sensitivity crisis, an internal evaluation cycle that conflates stability with truth, and a fundamental lack of ground truth for evaluation. The authors advocate for a significant paradigm shift in how uncertainty quantification is approached for LLMs. This contribution outlines a clear roadmap for the research community, emphasizing better evaluation metrics, native uncertainty mechanisms, and anchoring verification in objective truth. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.